In this video, let's take a look at how via generative design we can very easily create a rather organic and complex looking built-in wall system. So generative design is the term for when we kind of like chain commands together to automate a lot of tasks. So you see, for example, this furniture piece has a lot of vertical wall elements, but it is actually only just one simple object, which is simply being sliced by another object, which itself is just a plane. Okay, so how did I create all that stuff? Let me select all this, and I will delete the elements, and we'll get started. So let's make a new collection, and we call this one wall system. Okay, so Shift A, make a plane, and then we can move this plane up. Go to edit mode, RY90, point select, move this over, there, there. Select this edge, bring this over, and here move the stone, and we snap you to the bottom of the baseboard. Okay, so later we know actually the baseboard we might have to adjust, and so this is super tight. The door actually needs to move a little bit. Okay, so we can select everything and then E and extrude this a little bit, maybe by 2 inches and negative. Okay, let's check actually the face orientation. Now we see it's all red. So here, turn this on, press A, and then mesh and calculate outside. Cool, that's better. Before we continue, maybe at this point it might be a good moment to move our door. And this is because of how we set everything up, quite easy. So here we have our door trim. There is everything for the door handle, the door itself, and then G and X. And we move this by -2 inches. Let's see. Well, okay. Let's actually rather snap this to here. So now this is flush with the wall. Very good. And now as a second time, I move this away from the wall, -3 inches. So we can actually much better really be in control of where the stuff is. So now we have a 2-inch gap there. Yeah, okay. That's kind of fine. Tight, but good. The only problem, as you can see now, is everything else is not really working correctly. So where are our openings? So there they are. So this one we can select and move this over and simply snap to the door or the trim. So that should actually be perfect. It is. Oh, what happened here? Shift S, cursor to the selected, selection to cursor, there, finished. Alt H, good. Here, edit mode, AA, deselect everything, select this and snap this back. AA. Yeah, what do we do here? So when we actually build in this wall system there, then this part of the baseboard we don't need. So A, select all this, X and delete, and then B, select all this, S and X, 0, F, A, and I'm just calculating everything outside, and we keep it where it is right now. Okay. Very good. So, how do we continue? I will to make my model a little bit cleaner, select the back faces, Shift S cursor to select it, and in object mode, set my object center point to there. Then in edit mode, I will select everything and give this a good crease of 1. Now when I go to subdivide surface, maybe 2, and say smooth shade, and turn auto smooth on in edit mode now, Control R. Yeah, how many do I use? Let's say maybe 2. There. And then these 2 I can select. We'll move out a little bit. And you see how this nicely pillows. So this is actually a similar model or geometry trick we used also for the iPad back. I hope you start noticing how repetitive these commands are. Maybe this whole is art, and then here it goes flush. So we can play with the look a little bit. Maybe we only do it this way. What about this? Interesting. And maybe this one we move forward. I don't know. It doesn't matter much because the shape we can always modifying and go back. Maybe here, a little bit like this. Cool. So how do we get these cuts? Now in top view, Shift A, we make a cube, and we can specify. So how big should be the gap, and how much material thickness should we have? Let's say Y is 1 inch. Okay. Then we move this one to here, actually above it, and down to there. We keep this overlapping left and right, that is good. And then we go into edit mode. Select the 2 top edges, move this up. Select the 2 bottom edges, move this down. Very good. So you see again, we are overbuilding. And then we will go into array modifier. Now wrong direction. What about Y? That's a correct axis, but also wrong direction. -2. So 2 means the thickness or the width multiplied by 2. That's the reason why we have this gap. So 1 inch, 1 inch, 1 inch. And then we can increase the count. Very good. Okay. Also here, we will turn this into a wireframe so we can look into our object. Select this, save by the way, and then go to Boolean command, and we select this one. So this new exact works really clean, but it's also slower, more precise and slower. Fast, okay, there you see it. Is fast, but here and there has some little issues. So by moving this around a little bit, there you see we can fix these issues. There are some elements which are not cut correctly, and then there's an issue. So what's the problem here? Just so you understand, I'm going to select this face. This face is perfectly flush with this face. So that is where the math code has an issue. So I'm just moving the whole object, maybe a piece of paper to the left. Okay. There. Okay, so now the first one might not be really 1 inch, but all the others are 1 inch. And there we are. Cool. And when we bring this one down or bring this one up, there you can see how we can create these patterns. So when we go into this object and, for example, select this edge, bring this in. There you see, it's actually very easy to adjust. So quite nice actually how this works. Maybe these I will snap back to there. This one snap back to there. Okay, so maybe not making this wall too crazy. Can take a look from the top how this looks, or maybe this snap to there, this snap to there, so we make it flush again. So maybe just the mid part bellies out a little bit. Okay. So you see, you can explore ideas really quickly. I have this face here selected, Control I, or by hand we simply select all the outer points, and I will delete them. So because this is now a flat piece, let me go back to here and show this for the moment, solid. And then we will give this a solidify modifier, but at the beginning. And then we say this should be 1 inch. Please 1 inch minus 1, the opposite way. Hold on, what is going on here? Oh, this has a scale factor. This is why this didn't really work. Apply scale. Okay. So 1 inch. Zack. And then here are my cuts. Now if I say 2 inches, you see the material increases, and because we do a relative offset of -2, so 2 times the width, 55 count, you see how this very easily adjusts. And this is kind of like what is called parametric or generative design. I generate the stuff via math volume tool calculations. We could also call this parametric design because we're kind of like adjusting parameters. I think this is more in the realm of generative design because we're generating this stuff. Okay. Now this starts to look actually quite nice. So let's say we call this wall. Okay. Organic wall. Oh no, actually, let's see. We call this one wall body, and then we call these how should we call this? Wall slots. Okay. Then here I will add another detail to there. No wall slots. Bool if I want to continue my naming. So everything is nice and consistent. Keep in mind, maybe after 2 years you have hundreds of files. You want to develop a system how stuff you name. So it's always easy and repetitive. Okay, so we can hide this object, but we can still select it. We might, for example, want to add one more. What about another one? Yeah, look at that. Then at the end here we have this silly thing there. Constant offset. What do we have there? What does this one do? So along Y, 2 feet. I'm actually curious what this does. I might need to see this. Oh, minus 2 inches. Minus 1.1 inch. Ah, okay, good. So here with relative offset, it's basically the thickness of this, and then here I can specify via a value how much from there to there is the offset. So this is kind of like the alternative way how to do this. So how do we, for example, in this case, fix this? So yeah, we can just simply keep it like this. And if we want, maybe what happens when we try to center this? Yeah, maybe our object is actually just too big. So what about 1 inch? Okay. So we have more individual cuts. Yeah, it's hilarious. We just run into the same issue. But actually we can bring it to there, then we have that one. Maybe one less. Yeah, so it's like our start and our end, they are a little bit bigger. So here I will hide all this and bring this back, bring this to there. Yep. And just move this just a tiny bit over. Very good. I actually did not mind to have this clean entrance there. And that's also where, for example, the door goes into. So maybe we keep it like this. Let's actually snap this one to there for the moment. So this object is selected, and then rotate around the 3D cursor. 90 degrees. Okay. And there we can see it. Yeah. Also there, it bumps actually into it. So this means we might Control R, add one element there, and then this one we have to snap back to there. And probably the same here. Wait, this one actually went too far from a top view. There. They are actually all a little bit interestingly off. So I will select all those as X and 0. You see I'm back here bounding box, and then I can move this and snap better to there. Very good. Okay, cool. So this is our object for that. That is basically fine. Now, how can we add like a nice opening in there? So we make a Shift A, another cube. Then we can bring this cube to here. How high is this cube? 24 inches. So 12, yeah, so 2 feet. Very good. We can keep this actually really thick. This is fine. And maybe we make a design like this. So here we have one cube. It's always outside one of these elements. Shift D, escape, bring this one over, and then this one, Y, we make 48. Maybe to something like this. Okay. We can select both under Object Properties, Viewport Wire. When we hold the Alt key or Option, we can do this in both, and we push this one in there. And now when we select the wall, and instead of object, go collection. So wall Boolean. Zack. There it is. Wow. Pretty cool, no? Very easy. The last thing to do, how do we maybe add a nice horizontal insert in there so that if we want to put something into the cavity, it doesn't fall down. This is actually very easy. And the last missing piece in how to think about generative modeling here with Blender. So there is my rectangle I created. I move this snap to this edge. Go into edit mode, select all these edges, points, move and snap it to here. Very good. I can move this a little bit further back if I want to. Also here, I can adjust this to the wall. This is basically where it will truly end. A to select everything, Shift D and Y, move this over to there. And I snapped. Move, hold control, snap there. Material thickness, also here. 0.75 inch. Or maybe 1 inch, so it's the same like our other element. Complex or simple here in this case doesn't really matter. Yeah, so these boxes look a little bit dumb. How can we make this follow the surface? And this is not the interesting trick. We have here the wall bool. Let's make a new collection. And we call this bool. And this we drag in there. And actually, I forgot the name of this in English. So we're going to use the German word Ablage. And I just realized I said that even with an American accent. Fun fact, as you can hear, my voice has a German accent, and people in Germany would tell me my German has an American accent. No. Wah, wah. So here, wall body, we will call this bool and turn this Boolean off. Oh, wait. Delete it. This is important. Not Shift-D. We will make a linked copy, a clone. Press escape. No, don't move it. Wall body bool. Wire. Well, we can move this one into this collection here so we don't see it. Very good. Now we select this and tell here this Boolean object. Where is the? We can type in WA wall body bool. And good that I saved. Okay, so something went wrong. I have a suspicion that is because, let's say first, the back element is right at the end of this Boolean thing. So, few things. First, we will disconnect this association. Well, let's move this a little bit in so it overlaps. Very good. And let's try this again. Wall body bool. I'm actually surprised. Why? Let's go with fast. What's going on here? So, Shift H. So I see nothing else. Wall body. Wall body bool. Select this one. Oh, this has still the Boolean elements here. Playing my fault. Sorry. Ah, there we are. Good. Okay, so the Boolean object we made, the wall, we made a clone, and then we renamed this into wall bool. And I forgot for the second time to remove the Boolean cut. Now here we simply say intersect. And there we are. And you see we move this one up. How this moves inside this object. Beautiful. Q, outer smooth. So that's nice and smooth. Hide this. Wait, I mean hide the Boolean one. Alt H. Yeah, and there we are. Pretty cool, no? And now we can basically continue tinker with this. And this process, how I showed you how to make a wall, can literally be used for everything. If you want to make a table and have this type of a construction under it. Working with this process is also very popular in architecture. It's just generative design in general, where we mix geometry, deform it, do volume calculations, etc., and then create patterns which by hand are just way too complicated to work with. So you might ask yourself, class, you made a copy and then you said, nope, we needed to make a linked copy. What was the main reason behind this? So let me go back because I just realized I did not explain this. So here is my wall body bool, and here's my wall body. And let's go to here and say wall body. You see this shares the geometry. And also here, these knobs, for example, are individual objects, but they share the same geometry. And when we added that geometry in one body, let's say here, it will update it onto all other objects which are linked to it. So there you can see how I'm playing with this body. This is actually the body that cuts those two elements here. But since this object shares the same geometry as the main wall system, also the wall system gets the geometrical change. And that's basically the reason behind why we change something that way. Okay, very good. That is it for how to model this system.